Hi friends, I'd like to go over how to solve a matrix, solve a system of equations using a matrix. So let's just take a look at how we would solve a system of equations using the elimination method. So I could give you a system like 3x plus 2y equals 7, and let's go with x plus 5y equals 11. So we have our system here, and if I wanted to do elimination, one of the things that I could do is I could take this second equation and I could multiply it by -3 so that I got -3x minus 15y equals -33. And I could add that to 3x plus 2y equals 7. Can eliminate the x variable here, and I end up getting -13y equals -26, so y equals 2. Okay? So that's eliminating the x variable. I could also eliminate the y variables. If I wanted to do that, I could take this equation here and multiply it by, let's go with -5, or let's just do 5 on that one. So 15x plus 10y equals 35, and then multiply this guy by -2. So I get -2x minus 10y equals -22. The y's cancel out. We get 13x equals 13. So x equals 1. So notice that this elimination method is multiplying by a constant and adding equations, which are the same steps that are allowable in matrices. So these are the row operations here, multiplying by a constant and adding. So if I wanted to turn this into a matrix, what I would do is just go 3, 2, 7, 1, 5, 11. And my goal is to eliminate one of the variables. So I could do exactly what I did here, and I can multiply row 2 by -3. So I can do -3 row 2 plus row 1. And then I can be strategic about what I want that to replace. Let's go with just replacing row 2. So if I do that, I like to make a little placeholder. I don't like to fully change row 2 because we're just doing that as an intermediate. So I get -3, -15, -33, just like I did here. And I'm just kind of putting it here to remind myself that that's the -3 row 2. And then I'm going to add those. 3 plus -3 is 0. 2 plus -15 is -13. And 7 plus -33 is -26. And I'm not giving a command for row 1, so row 1 is going to stay the same. Okay? That gets me right to here. I'm not going to really divide by -13. I'm just going to multiply by -1 over 13. So row 2 equals -1 over 13, row 2, to get me to the y equals 2. So that gives me 3, 2, 7, 0, 1, 2. So y equals 2. So now what I need to do is I need to find some way to get some elimination happening up here where I want to eliminate the y variable in that first equation. And I've lost my second equation, so I really can't do it exactly the way that I did up here. But again, it's going to be the same system of multiplying by a constant and adding. So I have a 2 here. To eliminate it, I need this to be a -2. So what I can do is say row 2 equals, row 1, because we want to change row 1. Row 2 is set. -2 row 2 plus row 1. So -2 times 0 is 0. -2 times 1 is -2. -2 times 2 is -4. It's my placeholder for the -2 row 2. So adding those together, 3 plus 0 is 3. 2 plus -2 is 0. 7 plus -4 is 3. Row 2 stays the same, and that's actually easier mathematics than what I had to do up here. And then all I have to do is row 1 equals 1/3 of row 1 to get 1, 0, 1, and 0, 1, 2. 1x equals 1, and 1y equals 2, which is the same answer I got from elimination. It's just a little bit more efficient because we can combine the multiplication and addition into one step there. So that is how I would solve a 2-variable system using a matrix and connecting it to the elimination method.